Problem sheet 7, question 1. Consider the network below with road lengths indicating the distance between each city. Use dynamic programming to find the shortest path from A to J. Okay, so the dynamic programming algorithm we have looked at is value iteration. And in order to complete value iteration, there are 4 steps. So the first thing to do is formulate the problem as a directed acyclic graph. Now our problem is already a directed acyclic graph, and the problem is a shortest path problem. So this is done for us. The second thing we need to do is order the nodes. So we want to order the nodes in such a way that all downstream nodes have already been considered. So if we begin at the end, J, there are no downstream nodes, and so all downstream nodes have already been considered. We cannot consider I next, as H is a downstream node from I, and that hasn't been considered yet. So we have to go to H next, as all of H's downstream nodes, which is just I, has already been considered. And then I, all of I's downstream nodes have been considered, that's only H and J, so you can put I next. G, all of G's downstream nodes have already been considered. F, D, E, C, B, and A. So this will be the order in which we will perform value iteration. So then we have ordered the nodes. Now we want to perform value iteration. So we want to, in the order that we've just considered, assign a value to each node. For example, consider F, a value associated with F will be the shortest path from F to J, given that we take the best path from that point onwards. And so we will consider for every node, each action that we could take, which is each path out of that node, that corresponds to going to any particular node. So the action will be what node do we travel to next. What will our immediate reward for following that action be, which would be the length of the path? If we were to take that path, then what would our value for our node be? That is the reward plus the value of the node we end up in. And therefore, what is the value of our node? So we'll first consider J. There is nowhere to go to, so say we go to some dummy node. The reward for doing that is 0 because it doesn't really exist. And so the value of J is 0. And we have considered J. Next we will consider H. There's only one place we can go from H, which is to travel from H to J. The reward we will get from doing that, 8, is the distance from H to J. J has a value of 0, that is the shortest path from J to J, which makes sense. So R plus F is 8 plus 0. There are no other actions to consider, and so the best thing we can do from H is to go to J, which will assign H a value of 8. Next we consider I. There are 2 places we can go from I. We can go to J directly, or we can go via H. If we went to J directly, that would ensure a reward of 2. Via H would be a reward of 3. If we went to J directly, then we will reach a node with value 0. The value of J is 0, so 2 plus 0. If we went via H, we would reach a node with a value of 8. 3 plus 8. So 2 plus 0 is 2. 3 plus 8 is 11. We are looking for the shortest path from this node to J. That would be 2 plus 0. So the value of this node is 2. Next we will consider G. From G we can take 2 actions. We can either go to I or to H. The length of those edges are 2 and 7 respectively. The value of I we've just found out is 2, And so if the edge GI was in our shortest path from G, then the value of G would be 2 plus 2, which is 4. The value of H at the moment is 8. So if we were to take the path GH as part of our shortest path, that would give G a value of 7 plus 8. 7 plus 8 is 15, which is smaller than 4. We want to take the shortest path, so the value of G is 4. Next, we will consider F. From F, there are 3 paths we can take. We can either go to H, I, or G with rewards 3, 2, and 4 respectively. 3 plus 8, 2 plus 2, or 4 plus 4. And so we take the minimum, the value of F, given that we're taking the shortest path, would be via I, which would be 4. Now we can consider D. There are 2 paths we can take from D, either to F or to G, with rewards 3 and 4 respectively. Now if we were to go via F, then the shortest path from D would be 7. If we were to go via G, then the path would be 8, and 7 is less than 8, so we'll assign D the value of 7. Next we'll consider E. There are 2 paths we can take, either to F or to H, with rewards 2 and 3 respectively. 2 plus 4, 3 plus 8, which is 11. 6 is smaller than 11, so E has value 6. Now let's consider C. There are 2 paths we can take from C, either via E or via G. The reward for taking each of these paths are 7 and 8 respectively. The shortest path from E to J is 6, that's the value of E. So if we were to take the path CE, then that path would have length 13. The shortest path from G to J is 4. So if we were to take the path CG, that would result in a path of length 12. 12 is less than 13, and so C has a value of 12. Now we'll consider B. The only path we can take from B is to E with reward 3. E has value 6, and so taking this path would give us a value of 6 plus 3, which is 9. That's the only path we can take from B, and so B has a value of 9. Finally, we'll consider A. There are 3 paths we can take from A via B, D, or C with rewards 3, 10, and 4 respectively. The shortest path from B to J has length 9, that's the value of B. And so if AB is on our shortest path from A, then the value of A would be 12. The shortest path from D to J is 7. And so if AD is on our shortest path from A, the shortest path from A will have length 17. And the shortest path from C to J is 12. So if AC is on our shortest path, then the shortest path from A to J will have length 16. We care about the minimum, the shortest path, so we take the minimum of these, and so A has a value of 12. We have performed value iteration, assigning a value to every node. Now we just need to read off the solution. So we performed value iteration backwards from J to A. Now we'll read off the solution forwards from A to J. And so we know that the shortest path from A has value 12, and we got that by taking the route AB. The shortest path from B has value 9, and we got that by taking the route BE. The shortest path from E has value 6, and we got that by taking the route EF. The shortest path from F has value 4, and we got that by taking the route FI. The shortest path from I has value 2, and we got that by taking the route IJ. And of course, J is our destination, and so the shortest path from J is 0. And so we can read off our shortest path as A to B to E to F to I to J, and we know that will have length 12.